Hi, I'm Stanley Matsuda, and welcome to my YouTube channel. Just kidding, this is my wife's YouTube channel, Deneen Matsuda. But she's actually on an airplane flying to Nebraska to spend the weekend with her cousins. So I told her, don't worry about making a video for this week. I'll make one for you. Well, do you remember last week, her video was on her students responding to the question, what do you remember about fractions? And she uses that to lay the foundation on how to teach and introduce fractions to her students. Well, maybe she'll make a video on all the different techniques that she uses to lay the foundations for fractions. Well, this week, she is teaching her students how to compare fractions. And so Deneen wrote me a little note because apparently I have bad memory. And it says here, the strategies Deneen taught her students to compare fractions. Number 1, think about it. Number 2, use fraction models. Number 3, put them on a number line. Number 4, convert to decimals. Number 5, butterfly method. Well, maybe in a future video, Deneen will make a video for all the different techniques and explain how she uses them to teach her students how to compare fractions. But today's video is on the butterfly method, and that's to answer Hannah's question. So let's do just a quick recap on the butterfly method. So let's say I have two fractions, 2/3, and I want to compare that to 3/4. So in the butterfly method, you circle the 2 and the 4, and you multiply those two numbers together. So 2 times 4, you get 8. And then you circle the 3, and this 3, and 3 times 3, you get 9. And those circles make the shape of a butterfly, so that's why I think it's called the butterfly method. Well, you compare the two products, so 8 and 9, which one is bigger? Well, the 9 is bigger, so I use this inequality symbol, and I just transfer that into the box in here. And so then I know that 2/3 is smaller than 3/4. And so Hannah says, how come the butterfly method works? I don't understand. Well, so I actually asked the question to ChatGPT. But before I read what I asked, I need to do a little background and lay a little foundation on fractions. So let's go over here. So I have a fraction a over b, and that's equal to fraction c over d. Where those numbers a, b, c, and d are in certain positions, we'll call this position number 1, this position number 2, this is position number 3, and this is position number 4. So position 1 and 4, that's A and D, that's the extremes. And in position 2 and 3, they're the means. I don't know who made those words up, but that's what they're called. And to explain why they're called extremes and means, we need to write the fractions as a ratio. So A over B is A colon B. That's the ratio. That's equal to the fraction C over D, written as a ratio C colon D. Now you'll notice that in the position 1 and 4 is A and D. Well, A and D are on the outermost edge of the ratios, right? And so that's why it's called extremes. And in the 2 and the 3 position, B and C are closer together, and they're called means. Okay? So here we go. A times D is equal to B times C. All right, so that's the butterfly method here, right? And so we need this information because these are the terminologies that I use when I ask ChatGPT why the butterfly method works. So this is what I said. If the product of the means does not equal the product of the extremes, right here, product of the means does not equal the product of the extremes, can you conclude if one fraction is larger than the other, right? These two fractions, is one larger than the other if I know these two? ChatGPT says, no, you cannot conclude if one fraction is larger than the other if the product of the means does not equal the product of the extremes. This is because the relationship between the means and the extremes of two fractions is given by the rule of cross multiplication, which states that the product of the means equals the product of the extremes only for a pair of equivalent fractions. For non-equivalent fractions, the product of the means will not equal the product of the extremes. However, this does not provide any information about the relative sizes of the two fractions. To determine which fraction is larger, you will need to compare their numerators and denominators directly, or convert them to a common denominator and then compare their numerators. Well, that's not true because we already know that the butterfly method works. So ChatGPT is just slightly confused about my question, and it's giving a wrong response, okay? For non-equivalent fractions, the product of the means will not equal the product of the extremes. However, this does not provide any information about the relative sizes of the two fractions. That's not true. So it's just a little bit off. So then I say, then why is it true that if the product of the extremes is larger than the means, then the first fraction is larger than the second fraction? ChatGPT responds, the statement you mentioned is part of the rule of cross multiplication for comparing two fractions. The rule states if we have two fractions, a over b and c over d, where a, b, c, and d are positive integers, and if ab is greater than bc, okay, it's greater than bc, then the fraction ab is greater than cd. In this case, AD is the product of the extremes and BC is the product of the means. We already know that. The reason why this rule is always true is that the product of the extremes, AD, represents the area of the rectangle whose sides are A and D, and the product of the means, BC, represents the area of the rectangle whose sides are B and C. Okay, now here it's getting a little bit more confusing. If AD is bigger than BC, it means that the rectangle whose sides are A and D has a greater area than the rectangle whose sides are B and C. This implies that the fraction A over B, which represents the ratio of the longer side to the shorter side of the first rectangle, is greater than the fraction C over D, which represents the ratio of the longer side to the shorter side of the second rectangle. So confusing, but we will get to the bottom of this. And this is what I asked. Can you explain the proof so a fourth grader can understand it? Okay, can you explain the proof so that a fourth grader can understand it? So this is what we're doing, right? We know that the butterfly method works. Then we ask ChatGPT, and ChatGPT says, no, this doesn't work. You cannot compare fractions. This is the only way. It has to be equal. But then it says, no, it can be. You can have an inequality involved, and you can compare and determine if one fraction is larger than the other. So then this is what I say. Can you explain the proof so a fourth grader can understand it? And here it is. Sure, I'll try to explain the rule of cross multiplication in a way that a fourth grader can understand. Suppose you have two fractions like 1/2 and 3/4. To compare them, you can use the rule of cross multiplication. Here's how it works. So let's write this down. 1/2 comparing it to 3/4. Multiply the numerator of the first fraction by the denominator of the second fraction. Multiply the numerator of the first fraction times the denominator of the second fraction. It looks like the butterfly method. And what do I get? 1 times 4 is 4. Then it says multiply the numerator of the second fraction by the denominator of the first fraction. So here's the numerator of the second fraction, denominator of the first fraction. Looks like the butterfly method to me. 2 times 3 is 6. Then it says if the first product is greater than the second product, then the first fraction is bigger. If the second product is greater than the first product, then the second fraction is bigger. If the two products are equal, then the fractions are equal. So in this case, 1/2 and 3/4 are not equal because 4 is not equal to 6. In fact, 4 is less than 6. So that means 1/2 is less than 3/4. Okay? So ChatGPT is explaining the butterfly method. Now here is the actual proof that a fourth grader should understand. Why does this work? Imagine that you have a pizza cut into slices. The denominator of a fraction tells you how many slices there are in total, and the numerator tells you how many slices you have. For example, 1/2 means you have 1 slice out of 2 slices. 3/4 means you have 3 slices out of 4 slices. Now let's think about what it means for one fraction to be bigger than another. If you have more slices of pizza, then you have a bigger fraction. Okay, if you have more slices of pizza, you have a bigger fraction. Well, you go 1 and 3, you're comparing how many slices, but that's wrong because you need to have common denominator, right? So ChatGPT just goes off in a little tangent that's inaccurate. So it says, now let's think about what it means for one fraction to be bigger than another. If you have more slices of pizza, then you have a bigger fraction. So to compare two fractions, you need to figure out which one has more slices. Well, it should say that we can't compare the 1 and the 3 just yet. The rule of cross multiplication helps you do that. When you multiply the numerator of one fraction by the denominator of another fraction, you're finding out how many slices you would have. Okay, so then now now ChatGPT is fixing the previous statement. How do you find how many slices you have? You have to multiply the slices you have with the denominator of the other fraction. And then you get how many slices. But here's how they explain it. The rule of cross multiplication helps you do that. When you multiply the numerator of one fraction by the denominator of the other fraction, you're finding out how many slices you would have if you had the other fraction. So if I have 1 out of 2 slices, and I want to know how many slices I would have if I was in the other fraction, it would be 4. Okay? So that works this way. If I have 3 slices for this fraction, how many slices would I have on this fraction? Well, that would be 3 times 2. That would be 6. Okay? So here, if I have 1 slice in this scenario, I would have 4 slices in this scenario. If I had 3 slices in this scenario, I have 6 slices in this scenario. That's what it's saying. And why does that work? So it's saying, so by comparing the products of the cross multiplication, you're figuring out which fraction would give you more slices of pizza. That's why it works. Okay, that really doesn't explain it carefully enough. It's still a little bit too abstract. Like, if I had a pizza with only 2 slices and I get 1, but then I have to have a pizza with 4 slices. If I took 1, that would mean I would be taking 4. And it's like, what's going on? Okay, so I gave this a lot of thought. And to me, what's happening is the explanation skips an intermediate step. Just like the butterfly method that Deneen was teaching her students skips an intermediate step. That intermediate step explains why this works. And without seeing it, it looks like, whoa, it's like a miracle. Like all of a sudden, bam, these numbers just like appear out of nowhere. All right. So let's do the 1/2 and the 3/4 first, with the steps being added in there. Okay. So here we go. I have 1/2, and then I have 3/4. Now I need to multiply both sides by finding the common denominator. So the common denominator would be, I would take both of these denominators and multiply them together, right? So I'm going to multiply 2 and 4. So that's 2 times 4. And then I'm going to do the same thing on this side. I have to take the denominators 2 and 4. All right, and then the denominator 2 cancels out with this 2, and that leaves 1 and 4. So we have 4 and 1. And then over here, this denominator 4 cancels out with this 4, and then I have 3 times 2. And then I have 4, and then I have 6. And then 4 is smaller than 6, so then 1/2 is smaller than 3/4. And this is the intermediate step that we're missing. You mentally have to think about what's happening here and here, okay? Here and here. That's the intermediate step that explains why the butterfly method works, okay? So let's do this example over here. So we have 2/3 and 3/4. So we have 2/3 and 3/4. Okay, then I'm going to go down on one step. So 2/3 and 3/4. I'm going to multiply both sides by the denominators that I have. I have a 3 and a 4. So I'm going to do a 3 and a 4, 3 and a 4. Well, the denominator 3 cancels out with this 3, and the denominator 4 cancels out with this 4, which leaves me here. These are the extremes, and these are the means. So the 2 and the 4, and then the 3 and the 3. Okay, so then here's the extremes and here's the means. We have 8 and 9. And then 8 is smaller than 9. So then this symbol goes up here. Okay, will a 4th grader understand how this property works? That if I multiply this exact same number on both sides of the equal sign, that the equation maintains its equality? Well, that's what Deneen will have to teach her students. And how if we have a number in the numerator and a number in the denominator, and it's the same number, that it can cancel each other out. Well, that's another skill that she needs to teach her students and explain why that is true. Another thing that will need to be explained is that this number looks like it's written in the middle between the fraction 2 and the 3. So that's another thing that needs to be explained, that whole numbers are actually still fractions. Like this is actually 3 over 1 and that's 4 over 1. And so you're actually multiplying fractions, and then so that students can't think that that 3 is in the denominator. It's actually still in the numerator, even though it's written in that position. So those are some things that need to be explained before one actually understands why the butterfly method works. But the bottom line, the butterfly method cancels out all these intermediate steps. Okay, you just go butterfly and you get the product and you compare the product, and the comparison of the product translates to the comparison of the fraction. So I hope this explanation sort of helps with understanding why the butterfly method works. And if it doesn't, write some comments and we will try to answer them. In the meantime, thanks for watching. And if you liked the video, say like. If you disliked the video, say dislike. And please consider subscribing. Thanks for watching.